I'm going to explain how to find the lowest common multiple. We already saw one method, which is finding multiples of the 2 or 3 or 4 numbers, and then you find the common multiple that appears first. That's the lowest common multiple. Now we are going to look at a different alternative where we'll use prime factorization. In this case, our example would be 15 and 20. These are the numbers whose LCM we are going to find. So we'll draw this tabular form, put our 15 here, and put our 20 here, and begin dividing, starting with the smallest prime number. The first prime number is a 2. Is 15 divisible by 2? No, we leave it as 15. Is 20 divisible by 2? Yes, you write the 10. We go to the second line. We now have 15 and 10. We again continue. Can we still continue dividing any of them by 2? Sure, 10 can still be divided by 2. So we write a 2 here. 10 can be divided and we get a 5. Can 15 be divided by 2? You guess right, it can't. So we leave it as 15. Now 2 can't work anymore because both of the numbers are odd. So we go to the next prime number, 3. Can 15 be divided by 3? Yep. So one of them can be divided by 3. So we write our 3. 15 divided by 3 is 5. Can this 5 be divided by 3? No, it can't. So we leave it as a 5. We proceed to the next step. We have now 5s. None of them can be divided by 3, so we go to the next prime number, which is 5. Once we have done this, we now get all these numbers here, these prime factors here, get all these prime factors and get their product. That means we multiply them. So when we multiply them, we have 2 times 2 times 3 times 5, and that is going to give us the LCM, which means here we have a 4 times this side is a 15, and 4 times 15 gives us 60. Our conclusion is the LCM of 15 and 20 is 60. So you can do this for even numbers that are not 2, more. They could be 3 numbers. You go working out the same way. So we'll see if we had 3 numbers, how would we find the LCM? Let's erase all this and start again. 3 numbers. Let's say we have 10, 12, and 15, and we want to find the LCM of these numbers. How do we go about it? Same procedure. Fit them all in these tables. We have 10 here, we have 12 here, and we have 15 here. Okay, we begin working out. Begin dividing by 2. This works out, we get a 5. This gives us a 6. This remains. Next we try, does 2 still work? Sure, 2 works. 2, this remains a 5, doesn't change, this becomes a 3, and this remains a 15. Is there any of them that can still be divided by 2? Nope, there is none. 5 can't, 3 can't, 15 can't. We go to the next prime number, which is 3. Try, divide by 3. 5 it is not divisible by 3, so it remains a 5. 3 is divisible by 3, it becomes a 1. 15 is divisible by 3, it becomes a 5. We go to the next prime number, which is a 5. 5 divided by 5 is a 1. This remains. 5 divided by 5 is a 1. So in the end, we are going to multiply these prime factors. And so we will have 2 times 2 times 3 times 5. Okay, it's a coincidence that even here we have 4 times 15, and that gives us 60. So the LCM of these 3 numbers, 10, 12, and 15, is 60. If you try to use multiples, you'd see the multiples of 10 got 10, 20, 30, 40, 50, 60. And when you go to 12, you have 12, 24, 36, 48, 60. That's the first one that is similar to the one of 10. And when you go to 15, it goes 15, 30, 45, 60. So you see, so the lowest common multiple or least common multiple is 60, and that is how we find it